Hey guys, what's going on there? This time I will show you how to implement an infinite scrolling in React. Infinite scrolling is a powerful technique for dynamically loading content as users scroll down the page. So instead of displaying all content at once, like for example traditional pagination, infinite scrolling automatically loads more elements as the user approaches the bottom of the page. Besides being a great feature to add to your application, it's a common question in job interviews. And in such technical exams for job interviews, it can be quite tricky if you don't have a clear understanding of how it works. And considering in those cases you don't have any help, it means you are alone with the screen, so you should be well prepared to answer that question. So let me show you quickly what we are going to do today. I have created a simple React application that fetch data from Pokemon API. Keep in mind that in job interviews, in some cases, they provide you with an API to query during the interview, but in other times they tell you to find one yourself, and that is what we're going to do now. So as you see, it can the infinity scrolling works perfectly, and for that the Pokemon API is suitable for us for doing this exercise, because infinity scrolling is after all a technique to organize large amount of content. So when the amount of information is considerable, presenting all this content at once can be overwhelming for users. Therefore, to make user experience more friendly, this feature is great. In this sense, it would not make sense to implement it when the API provides us with not so much information to navigate. So this is our starting point. I already set up some basic components with their HTML and styles, so that we can focus on implementing our infinite scrolling feature. So the basic structure with the necessary components are already set up. So as you see here, we import the necessary modules from React, Axios for making HTTP request to our Pokemon API. The list component I already done for you in order to render our data. So this files, it's like our main component of our whole application, where here we use the useState hook to create or to store our Pokemon data. Loading, that indicates that our data loading is in progress. Then we define here our base URL, which contains our URL of the Pokemon API, and in this return we render our component. So now let's focus on our main topic, and for that we will have to execute the function that fetch the data of this API. And I want to make sure that I do that when the component mounts. So for that I will use this hook, useEffect. UseEffect is a hook that allows us to execute side effects in function components, which can include fetching subscription or manually changing the DOM. But in this case, we will do fetching this API specifically. So So once you are inside this hook, you can define any function you want. Any function you want to execute as side effect. So in our case, we will write, and here we will define an asynchronous function that indicates that the function will operate asynchronously, meaning it will pause execution to wait for the promise to resolve. So here we will write the keyword async. And here in the body of the function, we will define the logic, starting by setting the loading to false. Which indicates that the fetching is in process. Now let's write our try catch block in order to handle errors that might occur during the execution. Let's write a constant that we could call response. And here is where we will make our HTTP call request to fetch our data. Backtick, $, call basis, and base URL. Oh, this has nothing to do here. Let's remove it. And we add it here. So now we should be getting the data. Let's console log. Response, and then we execute fetch data. Well, let's see what we are getting in the console. Object, data, results. So in this case we will just get the name, because according to the documentation, in order to render the image we should make use of an external URL, but it doesn't matter, with the name it's really enough. Now let's see what's next to do. So now it's time to update this variable with what we are getting here. But first of all, let's correct a mistake I made right at the beginning. That is, this set loading should be true, and now false. This false indicates that the fetching process is finished and the component is no longer in the loading state. So my mistake, I'm sorry. Now let's update our component state with the data that we already got in this response constant. And now we have to access to our data object that is here, data dot result. and here is when we have access to all this data. Results. And in order to access the name of each Pokemon, we should here apply the map method. Item dot name. So now we are supposedly ready to render our Pokemons, because this is already set up, and except that we did not still pass our Pokemon variable props. And list, we also should pass Pokemon. And as you see, they are already, but we are getting only 20 Pokemons, I guess, 20 or a little more, not thousands of Pokemon as we should, because when accessing the endpoint, the Pokemon endpoint, the API does not return the entire dataset of Pokemon at once. Instead, it returns a paginated response, where the dataset is divided into smaller pages. So according to the Pokemon documentation, there are many ways to get more than 20, as we are doing now. As default, they give you only 20, but if we, for example, we want to render 100 Pokemons, we can add here limit equal to 100, and in this way we get 100, which is more than just 20. So this is how this API works. But in our case, what we want to do is to access to the entire dataset. Therefore, we should implement the alternative they give you to navigate through the pages. So we should implement pagination parameters inside this URL. So this is important for implementing then our infinite scrolling, because those parameters will be like our basis for implementing the infinite scrolling. And this is how it will look like with our parameters. We remove this limit, and first we write offset, and the other one will be limit. So in this offset parameter, we will specify the starting point in the data set from which to return results, or the number of items to skip before starting to collect the items to be returned. So here we will calculate the offset for pagination or infinite scrolling, like we are going to implement now, and it will look like this. So page represents the current page number of the pagination. It typically starts from 1 for the first page and 2 for the second page and so on. And this -1 is because since the API's pagination starts from an offset of 0 for the first page, we need to subtract 1 from the page in order to adjust the page number to 0 based indexing. Once we have the 0 based page index, we multiply it by the number of items per page to calculate the offset. In this case, each page contains 20 Pokemon. So, multiplying the 0 based page by 20 gives us the starting index of the current page Pokemon data. And here in limit we will repeat 20, which is the number of items per page that we want to display. So let's leave this part as it is for now, and let's focus on our infinite scrolling, and then we will come back to finish up with the details. And we will start now with the code responsible for enabling infinite scrolling. And for that we will start by writing another use effect. Remember, we can write this as many use effects as we want in order to make our application run. And this part of the code sets up event listeners to detect when the user has scrolled to the bottom of the page. And when this happens, it triggers the function that we are going to write now, which increases the page number, initiating the fetching additional Pokemon data. And for this, inside of our use effect, and within the use effect, we will start by defining a function. And now, before writing the body of this function, we will add a line below, right here below. And that line will add an event listener to the window object for the scroll event, so that when the user scrolls the web page, this function will be invoked. This function will contain the logic to respond to scroll event. So why window? Remember, window object represents the browser window in the browser's JavaScript environment. It serves as the global object for JavaScript code running within the browser. So attaching or adding event listener to the window. This event listener allows the code to respond to various browser level events such as scrolling or page loading. And here as the first argument we put the scroll, and by listening to the scroll event on the window, the code can detect when the user scrolls the web page, making it possible dynamic interaction and functionalities. And now we will return a cleanup function. This will remove the event listener attached to the window object for the scroll event. So when the component unmount or when the dependencies array of the array changes, this cleanup function will be invoked. So by removing the event listener, it frees up resource and improves performance by stopping event handling logic associated with scrolling. So now let's focus on the logic of handle scroll function. We will start by defining a if statement. So this logic should detect when the user reaches the bottom of the page, and we will start by defining here window dot inner page. Window dot inner page is the edge of the area in your browser window. It's the space you have to see the web content vertically, and when you resize your browser window or scroll up and down, this value changes to adapt to the new size or position of the window. Plus document element dot scroll top. So this document element dot scroll top represents simply the current scroll position. Plus document element dot scroll edge. Document element dot scroll edge represents the total edge of the web page, including content not currently visible, and it provides just the vertical length of the entire document from top to bottom. And why this +1? This +1 is a buffer added to ensure it means 1 pixel, and by adding 1 pixel, it anticipates the exact moment when the user reaches the bottom. And this small addition, 1 pixel, helps trigger the page incrementation when the user scroll it to the very bottom. So understand it like a calculation using the measure or the measurements from the DOM elements or of your browser window. The measurements of your browser window and the entire web page. It is just checking if you're at or near the bottom of the page by adding your Windows visible edge to how far you have scrolled down. So it combines the edge of the visible window with the distance scrolled down, and compares it to the total edge of the web page. And adding 1 pixel ensures precision when the user is at or near the bottom of the page for action like loading additional content. So when this condition is met, it will increment the page number that we defined in this use state by updating the state using set page. And that's what we are going to do right now. Set page. So by defining this prep here, we are making it sure that the new state value for page is based on the previous state. So if this condition is met, we will increment the page number, initiating the fetching of more content using infinite scrolling. So if everything is alright, we might be ready to try our application. But let's make sure nothing here is missing. Here I'm missing the dependencies, the array, the use effect hook dependencies, page, and the other one, base URL, which are very important because they ensure that the effect runs whenever either page or base URL changes, which is important for updating the data when the user scrolls or when the base URL changes. This is very important. What I just forgot. Without it, the component might not respond to this change. It helps in keeping the application state up to date. So by defining these dependencies, the component remains dynamic and it listens constantly to changes. So let's now save our changes and let's try if it works. It's not working. Let's see why. And the problem might be here because I'm not concatenating correctly the 20 items with the 20 next one and the next one and so on. With this code, I'm replacing the old list with a new one each time. And for things like scrolling, you probably want to, no, you sure want to keep loading more Pokemons without losing the ones you already have. So make here a small change. Spread operator. And so here we are spreading out the existing array, the existing 20, first 20, and then the new ones. Let's see if it works. And now it works perfectly. Our infinite scrolling is working perfectly. So in this case we are combining these two, we are separating the first 20 with the other by converting them in different arrays, and we are concatenating them to the existing list rather than replacing it as we were doing here. So that's it for this exercise. I hope you have enjoyed. Thank you very much.